Most finite element analysis tools do a good job of handling what's known as linear simulation. Some tools also claim to handle nonlinear simulation, but leave users struggling to get accurate answers. If you're hitting the nonlinear capability limits of your FEA solver, MSC can augment your FEA toolset and help you properly address this critical area of simulation. This is a stress-strain curve for metals. Metals are the easiest to handle in simulation in terms of their behavior. Notice the small region on the left where stress and strain are linearly related. Not all materials have that linear zone, but as you can see, even the behavior of metals gets complicated and nonlinear after the yield point. Think about all the materials that make up your product. Materials such as glass, paper, rubber, foam, they're all extremely nonlinear in nature. If your FEA return on investment isn't cutting it, it might be that you need to improve your ability to handle these kind of nonlinear materials. Nonlinearity goes beyond just materials, though. The way parts and assemblies interact is also often very nonlinear. Real-life scenarios such as bolts, rivets, gears, and other contacting bodies need to be studied with a quality nonlinear solver. Beyond product design, nonlinear issues often pop up on the manufacturing side of the house too. Forging, rolling, cutting, welding, all of these are highly nonlinear. Exotic glasses, rubbers, and shape memory alloys pose another challenge. Their material characteristics are quite complex and require far more capability than you'll find in basic FEA solvers. Crack growth, glue peeling, and composite delamination are other areas where typical FEA tools may struggle. Again, MSC software offers the experience and technology to get these problems done right. One of the biggest challenges most nonlinear solvers face is they cannot handle the extreme deformation that happens in plasticity or hyperelasticity, where the finite element mesh gets highly distorted. When elements are distorted, the assumption of a finite element having a certain shape doesn't really hold true, and the analysis simply stops. MSC has a unique way of dealing with this. Our mesh adaptation technology automatically enhances the mesh refinement and element quality as called for by the solution process. This happens automatically during the analysis and does not require user intervention. No matter what tool you're using, nonlinear analysis can get really compute intensive. If you're experiencing excessively long solve times, MSC will give you a huge speed boost in a couple of ways. DDM stands for Domain Decomposition Method, where a model is simply broken into pieces, and those pieces are solved separately on different CPUs. The second method is parallelization at a matrix level in MSC's advanced solvers, which further enhances compute time through shared memory parallel and distributed memory parallel setups. Contact is very difficult to address in most nonlinear solvers. It can be quite the manual job to define contact bodies, the stiffness contact interaction pairs, and tweak parameters to babysit a finicky run to completion. MSC solvers don't know how parts might contact ahead of time. No need to set up contact pairs, just let the program figure that out. The same goes with contact interaction. Our solvers will figure out the interaction and you don't have to specify the stiffness. Finally, our robust contact algorithms get you to a solution without all the tweaking and babysitting. Now, you might be thinking, this sounds great, but what would I do with all my existing ANSYS models? Well, you could certainly export the geometry of your existing ANSYS models in IGES, STEP, Nastran BDF, or Patran neutral files, and read those into the MSC products. But our preprocessors can also convert your ANSYS models to an MSC format to directly read in nodes, constraints, loads, and material properties. Contact us here if you'd like to learn more about improving your capability to address nonlinear issues in your product development process. We'd love to talk about your situation.